I prepared a Mentimeter projection. So I will share my screen. Let's see if this works. Oh, no, it's not. Now it should be visible, right? So the way that you can participate is that you go to this menti.com website. You can do it on your phone or just use you can open a new tab in your browser. And then you put in this code that's at the top of the page. And just give your opinion. Why should a math class be more creative? What are the problems that are occurring in your classes that you want to solve? What is missing in your math class that you would like to add to the class to make it more fun, to make it more efficient, to make it the learning more productive, to make the students love mathematics more, to help them realize that mathematics is really a great subject. So I'll open the results and we will be able to see the results that you put in your. So when anybody will write something, it should appear. Has anybody put in anything yet?
Typing.
Oh, no. It usually works. Hazi, have you put in anything? Because you answered.
I haven't pressed enter. I have time typing.
Ah, okay, sorry.
That's okay.
Okay, so it looks like it's working. We are getting some great comments. I'll just give you a few seconds to read them out to yourselves. And if you want to comment, of course, you can do it already. I think that this blue comment is something that we all aspire to.
I'm amused by the saying I don't know, because at least I have students who they quickly say I don't know, and then I ask how long have you tried, and it's usually less than it's almost immediate, and they don't even understand the concept that if they tried more they might discover something. It's very interesting.
Yes. And I think that this happens like internationally. There's no classroom that doesn't happen. I usually give them a question back. What do you know? What do you know? So start from there. So if you don't know this, something you must know. So let's start from there. And then we will gradually come to the answer to this question.
Do you get the answer? Nothing. I don't know anything.
Yes, well, you know something. Of course, you know something. Give me that.
I know. It's just so funny the way it goes.
Yeah, I know.
I don't know anything.
I was doing an activity of drawing a graph of a logarithmic function. And it's just like a basic activity where they would use, like they would put in x's, values for x's, and then compute back the values of y, and then just graph the dots. And this girl would say, well, I don't know what a logarithm is. How am I supposed to do this? Well, okay, then just go back to the first lesson, go back through your notebook and just learn what a logarithm is. You will draw a graph later on, don't worry. Just go to the basics. And then she did that, and then she was able to do the graph in a few more minutes.
It's funny talking about logarithms because I always use that as an example. I say I can walk into a class that's been studying logarithms for a week and ask one simple question, and I'll never get the right answer. I'll say, what is a logarithm? They have no idea. They've been doing it. So what is it? And then you just simply say it's an exponent. A logarithm is an exponent. You know, what does log of 100 mean? Log of 100 is 2 because the exponent is 2. But they don't learn things that way. You know, they just want to know how to do the problem. They don't know what it is. So I like logarithms.
Yeah, and logarithms are famous for being something that is just like, what's the point?
Obscure, right? Yeah. Unimportant, right?
What's the point of this? Why do we need logarithms?
We're never going to use it.
Yeah. And then I started the lesson with one class. I said, has anybody heard of logarithms yet? And two students raised their hand and said, yes, we did. And I said, what was the emotion that you got from that person who told you about logarithms? Was it a negative? They said, yeah, it's something negative. It's not good. I said, yeah. Probably for the next half an hour, you will look at me and say, what's the point of this, professor? What's the point of this? And I will try to explain it to you. For the first few hours, well, for the first half an hour, you will hate me. You will not understand what we are doing this. But I will try to explain it to you and give you an example of why we are doing it and what's the point of it. And then later on, I think that I managed so that they at least accepted it and learned that there is, people are using logarithms in real life. Actually, they are. So it's important to understand it.
Just one thing that Nishant was saying, that you brought up, like, do you know the meaning of logarithm? Well, I've done that with high school students with, do you know the meaning of multiplication or division?
Right.
And they often don't actually know.
No.
That makes it so you can't actually build on what we're working on. And the same thing with logarithm. I had to spend, what I've noticed is that they have really little experience with learning meanings of things. and so therefore we put in a lot of effort into just taking in the meaning of these different terms.
Yeah, geometry is a really good opportunity for that, because I know the old style of geometry would have them memorize all these meanings, all these theorems. And I always tell them, you just tell me what you're looking at. Can you describe what you see? They're such simple concepts, but they're not used to looking at something and describing it. And part of that is English, just, well, whatever language you're in, being able to describe things in your language, with good words, and to incorporate math vocabulary into your language. And so it's a really good skill, and they don't develop that very well.
Oh, and it's because they're just solving exercises, I think.
Yeah,
because
they just want to get the answer.
I also realized that what you said, Nishtan, is I often tell them exactly what you tell them. So just tell me what's there. What are you looking at? Just tell me what it is. You have eyes, you can see,
Mm-hmm. Yeah.
and they're just afraid of, saying something wrong.
Yeah.
So
Yeah.
one of the first things that I did here at a public school is just, making sure that they feel safe, that they can express, that they can say whatever that they see. And I said, well, just say something and it's fine. If it's wrong, it's wrong. I'll just give you a hint, maybe point you into the right direction, and we'll take it from there. But if they are too afraid to say something because they feel that they will be judged upon what they say, they will not say it. And if maybe, and also I try to tell them, well, just use simple words for just at the beginning, and then we will try to implement and say it with the mathematical vocabulary, because the mathematical vocabulary is there just to make things simpler, so that you don't say, well, the point where the two lines intersect, right? You can just say the intersection. It's just much
Right.
simpler. That's why we have those words, just to make the life simple, not because we want you to learn those new words so that you can then use them when you have an oral exam. That's not the point. Okay. So
I have a question.
Yes, sure.
Have any of you done an exercise where you ask the kids to purposely answer wrong? Like they could just practice being wrong. That might be like a fun thing to do. Just to icebreaker.
I think that Vasco, you were talking about something similar in the spring conference when you were solving equations, I think, and you asked them to purposely solve it the wrong way, just to help them let go of the fear of doing something wrong.
Yeah, it's true. I've done that in the past just because the math is pretty exact as it is, and that's the reason I think that why because they are aware of it, not like in maybe some other subjects where it could have depended on the point of view or just an opinion-based answer. It's really exact, and they are afraid that they would not choose the right words. And also in my group age, when I teach, it's also the importance for them about their teacher's opinion of them, because if they make a mistake, then they were afraid that the teacher would have a negative opinion of them, or because they didn't study, and that they would like to impress you. And that's something I think that it's really important to acknowledge and work your way around it in the most possible and creative way. So that's what one of my attempts was, the solving the equations the wrong way, and then figuring it out like step by step, one thing correct. Just the next line, do something with it, just simplify it a little bit, and then try to do it one step at a time, but small correct steps. And then when they break down the equation in that way, then the mistakes are not as big as that the whole equation would be incorrect. And so you have something going on their list. You can go, okay, you've done this great, you've done this great, you've done this correct, great job, you're on a great way. Just solve this step now, and then you're one step closer to the correct answer to the equation. So yeah,
Okay.
breaking the problems down into the smaller steps, I think it's really important. And if I may add, the one thought that kept popping to my head while you were all discussing, it's that the math, the answer, I myself as well, I do encounter the question, oh, what is this for? Where I'm going to use this formula or concept? And my answer to this is basically always the same. It's not about the concept or the formula or the exact thing that we are doing now, that we're learning in math. It's basically the way of thinking. The math, I think it's great, like an amazing tool through which children can develop a certain way of structural or problem solving. Like step-by-step problem solving, like breaking down the problem and then solving it step by step. And then this knowledge they can acquire through math, they can apply it to real life situations outside the class, like car crash or anything that they have a challenge with. Okay, this happened, what's my next step? This and this. Where I'm going to start here. And then check it out, make a plan, and then figure it out. That's the tool. And it usually satisfies them, like this, the answer. They are okay. I get the idea, and they are not being
Resisting.
Yeah, thank you very much. Yeah.
Yeah, it's really the best answer because it's the truth. When am I going to use it? The answer is all the time. Use it all the time. And it really is true about other subjects in school too. It's not the facts that you're learning that are important. It's the process of learning and using your mind that is the most valuable in every subject, really. Yeah.
Yes, I agree. Okay, so I got so Hazi, did you want to say something?
Yeah, I wanted to just build on, well, first off, that point about breaking things down into from hard to simple. I think for me at least, that's one of the special features of math. So that's something I'm always trying to emphasize, is that all of this looks intimidating from where you look now, but as you look closer, unlike science, it's actually going to get simple. Now science, when you look closer, it actually gets more complex. I mean, if you try to understand an atom, it just gets more and more complex, but math, it just breaks down into simple. So that's one of the beautiful things about it. And it's easy at the end of the day. So that hopefully to get over the intimidation factor. I just also wanted to share, because we were talking about problem solving and creativity, something I found to be really successful is I do half time, I just have them do problem solving at their own pace through some books of problems. And what I've found, and I don't grade them on correctness at all. I just grade them on whether it looks like they're putting in their energy. And I give them good grades also because it helps them feel motivated. And it's just so fascinating. I started getting all of these answers, which I don't even understand what they're doing. And sometimes they get the right answer and sometimes they don't. But they're coming up with ideas and approaches that I'm looking at it and I've never thought of approaching things like this before. And sometimes it's just flat out wrong. But I'm happy to see that they're actually starting to engage creatively with math. And so I just wanted to share that so far half time with problem solving has it's been a difficult thing for them in the start, but over time it's developed their freedom to be creative and try out things that might not be right. So it's very interesting.
I would like to add to this that I do private tutoring as well, alongside being in a public school and in EFL. And I see sometimes students come to me and they just tell me, well, just show me how it gets solved. You know, what's the procedure? What do I have to do? But that's not the point. You're supposed to, look at what you have and try to see how to do it. So I try to do that in with my homework. So I give them a few examples to solve it at home. And I tell them that it's the point of this homework is not to get the correct answer. So I will not, so I don't want to get 30 answers that are correct, but are copied from one person because you just want to have the homework done. I want you to sit down for half an hour, just half an hour, and just try something. And if after half an hour you have no ideas left of what to do, you don't know what else to do, you just stop and just return the homework to me. And in this way I get a good information, feedback information of where they are with their understanding. And so it builds on what you said, Hazy, that I want them to start just, what would you do? Just do something. What would your logic, your understanding, your already knowledge that you already have, what would you come up with? What's your answer? Yes, Vasco?
Yeah, also, if I can elaborate on that, it's the one thing that I noticed with the problem solving, not just like an equation, just like a written text problem, it's also the lack of their ability, like in technical reading, because I've noticed that they read the mathematical problems like literature, they would read like a fairy tale, just like from start to finish, like from a capital to the dot. And then they read the whole problem and they have the zero idea what they just read and they don't know where to start. And this goes into also, I've noticed that also they have a challenge creating and putting down the equation or from the text. They read it and they don't know how to set up their equations so they could figure out what the value of the problem is or the solution. They just go by, like, half of the time they try intuitively and they fail to recognize the problem, and they have challenges to write it down in the right structure.
Mm-hmm. So I would just like to warn you that I got a warning that we only have 2 more minutes, because but it's not because of the session, it's because of the Zoom, because I created this Zoom meeting from my private account, which is not an upgraded account. So I just propose that we just leave the meeting and then rejoin again on the same link, and then we'll have another 10 minutes of the meeting.
Okay.